Alright folks, on today's episode of building Yosemite Valley number 26, we're going to be doing the wheel sets. First starting off with the drivers. To start with drivers, you want to get a cylinder. Always make sure the positions of your parts are not some random garbage number. That's a random garbage number, you don't want stuff like that. Because it gets stuff to be offset and off increment, which is really annoying later on when you're rigging stuff. First, we're just gonna get the size, not the size, the diameter of the driver. Now we can just scale it up until it's about even on all sides. It'll be good enough for what we need. Next, what it'll do is get the tire spacing of how big the tires are, which is just how wide the wheel set is. Alright, now I've gotten the size of my tires, just 0.4 studs wide. Next, we're going to want to do the flange. So we're going to move out another cylinder so we can scale it up. I do 3 notches on the increment. It just seems to be a decent flange size, so it's not too big and not too small. What I like to do is I like to have a curve. So I go and create a special mesh and set the mesh type to be sphere. Now we've created our flange. For the sake of my own sanity, I'm going to set it to metal. So now we've got the base wheel. You could literally use this and it'll be fine. Literally just use the cylinder, you don't even need the flange. I'm going to make another copy of it and just move it out. This is for later, so we have the accurate size and it's not in the giant union that you have to ununion. Next, we're going to want to start cutting into the wheel set. By that, I mean using the gates and making unions. We can scale stuff down a little. Bring the drawings back over. And find about where it next seems to have a line, which is about there. Now this, you're gonna want to copy the both sides. This marks the tires of the locomotive. And then we're gonna do the inner actual wheel part of it next. We're gonna make another cylinder that goes across the whole thing. These two only go in slightly. And this, we're gonna want to take it to about the inside of that. So for this, about 4 studs in diameter should work. You're gonna get something looking like this. Now for all of these parts, you're gonna want to negate them. Then you can select all of them. Make sure you don't select your drawings. You don't want to union those. You can press union, and it cuts out whatever you've put your negates through. Now this creates the outsides of a wheel set. Now we're going to start working on the inside with all the spokes. We're going to grab another cylinder and just copy the one that we left over here. Scale it down. This is going to be the inside of the driver's center. Well, while we're at it, we can also get out the axle. Now, some engines don't have the axle sticking out, but for this, I'm gonna do it anyways. And also, I like the look of engines that have it. So it sticks out slightly from the driver's center. You can just scale it out. Whenever the axis that you're scaling it on, the one that's changing, whenever that gets to 0, that's how you know that the part is centered, and it's centered in the middle of the wheel set. Make them slightly smaller too, they're kind of big. Well, that is a good size for that. Now we're going to move on to the hardest part of doing wheel sets. making the spokes. How I do spokes is I stole a design. Yes, folks, that's right. I stole someone else's way of doing it. How evil am I? So, golden star highlight, or golden starlight, or whatever he's called, I don't remember. Something along those lines. And his 10-wheeler showed this off as a way to do it, and I really like it, so I use it. We're gonna see about the approximate size of it. Looks to be about 0.2 studs. That's a nice number. Now we're gonna wanna move it over till it reaches the edge of the tire, so it sits in it like this. We do that again on the other side. Then we're gonna duplicate it again, the middle, and scale it down till it's meshing on the centers of the two cylinders. We're gonna set shape to be block. This is one of my favorite things in the properties is at the bottom. You can literally just change the shape of it with that instead of having to spawn in a new part each time. We're gonna want to union the block and the two cylinders together. And now this is one thing. Now you can literally just have this and it'll look fine. You just have one big cylinder or a cube for the whole thing. Although, it's not the most detailed way of doing it, so I do it a little bit more of a detailed way. And this is where the whole stealing an idea came from. Is you get Archimedes. This tool is very helpful for building track and angling things off of other things. And that's what it's useful for. Basically, what Archimedes does is it takes the outside corner and it'll rotate it along it so you can get nice angles each time and you don't have to individually go through, grab your part, rotate it, move it. It's not easy. That's why we have Archimedes. It's your best friend. So we can grab a little segment of a spoke like this. And we're gonna Archimedes it to be a nice curve. And play around and find angles to look nice. 30 there looks pretty nice. We can do it on the other side. And now we've created a nice sort of mesh into the outside of the wheel set. Now it kind of looks ugly. We've got stuff coming in on each other. It's just ugly. And I don't like it looking like that. So we're going to take it all out. I recommend having a 1 stud increment so you can just move it back easily. We'll duplicate it, ununion all of them, delete most of them until you just have one end's worth. Set all these shapes to be block. And this is what we're going to use to cut out a centerpiece to fill in the gap there. Make sure you have your use local space turn on. And to do that, you can right click on it and there's a property called use local space. I know you can't see that. You want to set your increment to be half of whatever this length of it is. And if it's 0.2, we want it to be 0.1. We're gonna move them out. Well, in this case, move them down. And we get something looking like this. It looks weird, and it doesn't look like it's gonna do what it's gonna do. But it will do it. Basically, what it does is it just makes it so it won't go past the center of the cylinder, and it'll only fill in the middle, not the outside. Which, you don't want to fill in the outside because that breaks the whole point of having cylinders. And we're gonna put in a block and have it be like this. I'm gonna select it all, just not the block we just put, negate it, and union it. You can play around with the unions to get them to look nicer. Now I know this is a very strangely shaped one, but it should still get looking better. And look at that, it fills in the gap pretty nicely. You can play, smaller angles are gonna look smoother, but more angles for these also means more parts, which means more vertices, which means more lag. And it looks fine without the extra ones, so you don't really need them. Why waste the lag when you can just have that? Now we're going to want to take this part and move it down to the center of the driver, because the center of the drivers also need to have a little curve. This you really don't have to be super detailed with. You can literally do it with one and it'll look pretty fine. I'm going to take them out and do the same thing we just did. Don't delete your drawings, it's really annoying. We want to do the exact same thing that we just did. You don't want to do that, you want to duplicate it first. Now we've created that. Now you don't need to make new ones for each side, you can just duplicate them. Grab it like that, find the center of your spoke, copy that position, and go to create a model with the curvy parts. Set the world pivot to be the center of the spoke. And you just rotate them 180 degrees, and it'll be nicely on the other side. And ungroup those, and you can union them with the main part of the spoke. And ta-da, you've created one spoke. For the rest of them, you can literally just duplicate them around. And that will create your driver. Now that you duplicate the spokes all around, we can create the cranks. These drive the rods. For these, you want to just create another cylinder. Scale them down until they get to a somewhat decent size. 0.7 seems like a good one. You can make a part and put it like this. Grab Archimedes. And find the one that you want. And you can curve it into the center of the driver. That looks pretty decent. There are other ways of doing it, but this is how I like to do it. And you've created that. Now for the crank fins, you just need Another part that comes out the side, set to a relatively small size, and just drag it out a decent amount. We'll change that later when we build the rods. Now we need to do the counterweights. Grab another cylinder, get it to the size of your driver. Look at the drawings. You can see that it kind of goes outside of the inner tire area, or the inner wheel set area. I don't know what it's called. Most counterweights stick out a little, so you can have it like that. You create another cylinder out of it, and this is what we're going to use to cut out the counterweights. That looks like it'll cut out about the right shape. So you can negate it, union it, and ta-da, we've created a wheel. Now for the other counterweights, because there's two types of counterweights, there's a bigger one on the main driver. So as I am lazy and just feel like kind of cheating it, I'm not gonna grab the drawings, I'm just gonna scale it down and move it into an appropriate looking position. Put the other counterweights back on. Now we need to make the wheel on the other side. So you can group all of this side, set it across the axis you're building, rotate it 180, and then rotate it 90 so the wheels are quartered. Ungroup them, and then group the whole wheel set as one group. Ta-da, you've created a wheel set. Now for the other counterweights, you can just delete the counterweights you had, put the other one in, have it as a group, get the position of your wheel set, put it into the world pivot, you can rotate it around, and move it into the right location, and put them into the wheel set. Now you see we have a whole lot of unions of parts here, so we're going to want to union all of this together. Not all of it, we don't want to union the crank pins. Those will need to have attachments on them, so you don't want to union them. Putting unions on attachments can be really funky sometimes. Now you've created your wheel set. The only downside to having the whole thing unioned is you can only color it as one color. But for this, it doesn't need to have white walls or anything, so it works. If you need to have other colors, like your counterweights are a different color or something, you can have multiple different unions, or you can union out colors, which works too. I'm gonna do it for this wheel set too. Union all those. Now we need to create the colliders. These are what will actually be colliding with the rails, because Roblox unions have really stupid collisions. So we need to create a collider. I have all my colliders material is smooth plastic, and the custom physical properties. Make the density 100, the elasticity 0, put the weights of that to 100. The friction, you can set that high, and the friction weight can also be high. And that's how I always have it set up for my engines. Other people have it set up differently. And you can make them transparent. Oh, let's name mine Collider. Move them to the other side and put them in your group. You put them in the others. Always make sure they're centered on the wheels. And you've created your 2 wheel sets. We can select everything that's not a collider, turn can collide off, collision fidelity to box. That just means less lag. Make them anchored and massless. Always make sure your engines are anchored. That's very important, as it makes sure they won't fall apart when you spawn in. Looks to be about right. You can just move your wheel sets over into appropriate locations. And ta-da, you've created drivers. We'll go over making the other wheel sets when we do their associated trucks. So for this is the end of this tutorial, and we'll see you next time.